Um, this is Nawanga Alpha Data Science Year 2. I'm going to go through the introduction to machine learning. Um, Slide 1. Um, what is machine learning? Machine learning is simply a field of study that gives computers the ability to learn without being explicitly programmed. Like, it doesn't require someone to go ahead and program, but just works automatically, something like that. That's machine learning, the field of study that gives computers the ability to learn without being programmed. If I go to machine learning applications, I have applications like image and speech recognition. This is simply it operates in self-driving cars. Look at facial recognition. Then for natural language processing, look at language translation. For healthcare, look at disease diagnosis. Then the types of machine learning, we have supervised machine learning and unsupervised machine learning. As I try to give some diagram here to explain more machine learning, and then these are the types of machine learning. Then supervised goes through categories like classification and regression, then unsupervised learning through clustering, just like you see the procedure. Then if you go to another slide, that's the training and datasets. To set something on datasets, a dataset is simply something that is human refined, that does not have any noise. Yeah, that's a dataset. So its final form of the data that is about to be fed to the machine learning algorithm. Just like you see this example of the diagram that I put here, this is a data set. It's something that is human refined, like this was done by human, because from the definition of machine learning, it shows that it doesn't require the machine to be programmed. But this data set, it's human refined, like it was programmed by someone. So if we go to what training is, training is simply the learning process. And what processes do we go through during training? You can see solving questions, comparing with correct answers, self-assessing. Yes, self-assessing. Then you repeat that process, you get most of them right. Yeah. So let me talk about making predictions. To make predictions, this is after sufficient practice, it's time to test whether you're going to pass or fail. Remember, you're done training, so you go ahead to test yourself whether you're going to pass or fail. For the data set, you can go ahead and set practice questions, then training machine learning algorithm, solving questions and comparing with the solution. So for the prediction, this is simply about solving the exam. Talk more about supervised machine learning. This is simply a type of machine learning which requires human-labeled data, which provides the necessary supervision during machine learning algorithm. To talk more of supervised machine learning, that's the types of supervised machine learning. We have regression, classification, just like we saw in the first one of the first slides. Yeah, the categories of learning. We have classification and regression. Say something on regression. Regression is a type of supervised learning technique used to model and analyze relationships between dependent and independent variables. The goal of why we go through regression, the goal for regression is to predict a continuous output value based on the input features. Just like I've talked about the dependent and the independent. When I talk about dependent, I mean the target. And then for the independent, I mean the input variable. So the dependent variable or the target, this is the variable where we are trying to predict simply about predicting if you want to know the house price or the temperature, something like that. But then for the independent variables, those are the features. This is simply the variables used to predict the target. Like we remember, these are independent, these are simply features, so we use them to predict the target. That's, for example, the number of rooms or the square footage. Yeah. Then for the types of regression, we have linear regression, logistic regression, and decision trees. We have what we call classification, just like I said, as a branch of unsupervised machine learning. This is a type of has a branch of supervised machine learning. Remember, we have regression and classification for supervised. So classification is a type of supervised learning where the goal is to predict a discrete label or category for a given input. e.g. the support vector machines. Yeah, I'm going to say something about support vector machines later. So to continue and with unsupervised machine learning, this simply use unlabeled data sets, features represent information, study the feature to get more information, then learn from features using algorithm. So we have what we call clustering. Just like you hear a cluster, something like a group, something like that. So cluster, group, you go ahead and group together features that exhibit the same aesthetics. For example, different Netflix users can have similar preferences. So we have what we call hierarchical clustering. This is simply all about clustering into different groups. Then anomaly detection. In anomaly detection, this is simply all about detecting an unusual occurrence of the data instance in the data set, e.g. credit card fraud detection based on amount spent. To say something about models, the model simply, it's all about representation of some phenomenon. And to talk about this, like I've talked about a model, it's what we call a stat model or stat models. This simply describe relationship between variables. Have types of models that are deterministic and probabilistic models. So to say something about deterministic models, these simply hypothesize exact relationships. So they assume that the relationship between inputs and outputs is fixed and does not involve randomness or uncertainty. Yet in probabilistic, we can see something like randomness and uncertainty in their predictions. So hypothesis, two components, we have deterministic and random errors. So for the types of probabilistic models, we can see have regression models, correlation models, and say something on regression models. Regression model is simply about the relationship between one dependent variable and explanatory variable. So use the equation to step up relationship. So we have what you call response variable and categorical independent. This is the explanatory variable, something like that. Then the response variable involves numerical. Look, it's numerical in nature. Then the explanatory, it's categorical in nature, something like that. So for regression models, they are used mainly for prediction and estimation. So to say something about feature scaling. Feature scaling is simply about normalized and standardized data. For normalized data, it simply involves fixing range of data between two variables, e.g., a range between 0 and 1. For the standardized data, transform data to have 0 mean and SD1. So it controls the spread of data and localize it at center point. You can see the actual data initially it's like this. Then after normalization, remember we've said normalization involves fixing range of data between two variables. That's big. For example, between 0 and 1. So this was the data initially. Then after normalizing, we can see how the data is fixed, right? Then after standardization, this is how the data will appear. Say something on the k-nearest neighbors. You can see that in k-nearest neighbors, it classifies new data points based on majority class among its k-nearest neighbors in the training datasets. If I'm to talk about the advantages it has, it's simple, it's easy to implement, and no training required. For the disadvantages, it's sensitive to noisy data, computationally expensive for large datasets. Then if I'm to talk about the the K-nearest neighbor use cases. You can see text mining, agriculture, it can be applied in finance. Then if I'm talk about